Quicker than the actual design of spacetime itself, it has the influence to keep up with its consciousness of it. Thus, it will gradually dismantle this thought, filling me with a feeling of disquiet. As of now, our night sky is quickly changing, and inside the next few decades, perhaps sooner, it could turn out to be totally unrecognizable. Specialists, including Neil deGrasse Tyson, are sounding the alarm, recognizing the unavoidable changes brought on by the shifting of Polaris. The foundation behind this change is surprisingly unexpected. Polaris, generally known as the North Star, has been a reliable feature in the sky for centuries, serving as a fundamental reference for astronomers, pilots, and stargazers alike. However, this could soon be altered, changing the way we see the sky and study the universe. Let's examine what this change could mean for us. For a long time, Polaris has been a guiding light for mariners and stargazers, remaining firmly positioned in the sky. Its steady presence has been crucial for navigation, yet this stability may soon be disrupted. A paper from the Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a tumultuous phase, one where it could potentially explode, vanish from sight forever, and alter the sky as we know it. Before considering the possible outcomes of this event, we should delve deeper into the characteristics of the star itself. Polaris is distinct because of its proximity to the celestial North Pole, located directly above Earth's northernmost point. It appears almost stationary in the sky and resides in the Ursa Minor constellation, commonly known as the Little Dipper. Polaris shines with moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our own Sun. However, Polaris is not just a single star. It is part of a complex triple-star system, consisting of Polaris A and Polaris B as a binary pair with a third star orbiting them. The gravitational forces between these stars influence their orbits and behaviors. Disruptions in their interactions could cause shifts in their brightness or pulsation patterns. Nevertheless, the precise nature of these forces is still not fully understood. Polaris is located approximately 323 light-years from Earth, meaning the light we currently see from it began its journey centuries ago. If Polaris were to explode, we wouldn't observe the effects for over 300 years. It's even possible that Polaris has already exploded, but we have yet to witness it. Throughout history, the North Star has held significant cultural, navigational, and symbolic importance. Its consistent position has made it an invaluable guide for ancient mariners navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unaltered in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided vital insights into the properties of stars and the behavior of variable stars. This characteristic has also been key in measuring cosmic distances and calibrating scientific instruments. Recently, however, Polaris has started to show signs of deviating from its usual behavior. This anomaly in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unexpected changes. Instead of adhering to its normal pattern, Polaris has begun exhibiting erratic dimming, leading to concerns that the star may be nearing the end of its life cycle. This behavior aligns with what is observed in stars approaching their final stages. The gradual increase in Polaris's pulsation period, once consistent, has been traced back to interactions within its star system. There has been an annual increase of around 4.5 seconds in the pulsation period. While this may seem negligible, it carries significant implications. Some astronomers suggest that gravitational forces between the stars in the Polaris system could be driving these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to the similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars at the end of their life cycles often display such anomalies before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to fully shift toward Polaris. As a Cepheid variable star approaches the end of its life, it undergoes several stages, including the red giant phase and, potentially, a supernova explosion. Given the irregular pulsations observed in Polaris, scientists suspect it has entered a phase of helium depletion, common for giant stars nearing their end. These inconsistencies align with patterns found in stars on the brink of collapse. However, solid evidence of an imminent supernova remains uncertain, and astronomers are continuing to monitor these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a spectacular event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brightness could drastically alter our view of key constellations, such as the Big Dipper, Ursa Major, in which Polaris plays a pivotal role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes due to its size and distance from us. While the explosion of Polaris might not be as visually overwhelming as Betelgeuse's potential supernova, it could still be visible to the naked eye for an extended period, overshadowing nearby stars. This would undoubtedly capture the attention of astronomers and observatories, sparking widespread interest among both scientists and stargazers. However, the impact on Earth's environment or ecosystems would be minimal compared to a supernova closer to our planet. So, what will happen to Polaris itself after a potential supernova explosion? First, it's important to note that while massive stars typically end their lives in a supernova explosion, this is unlikely for Polaris. When a massive star undergoes a supernova, its core collapses, triggering a violent shock wave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a catastrophic event. Instead, once Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This process will not lead to a supernova but rather a quieter end. As Polaris evolves into a small, incredibly dense stellar remnant, its white dwarf phase will mark the end of its life cycle. A white dwarf, though roughly the size of Earth, retains the mass of the Sun. Once this transition occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, astronomers can gain valuable insights into the evolution of stars and their ultimate destinies. For instance, supernova events like SN 1987A, SN 2011 Fe, and SN 2014J have provided critical data that help us understand what might happen to Polaris in the future. For example, SN 1054 resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, offering astronomers a rich field of study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided fundamental insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries help us better understand the unique characteristics of Polaris. The formation of nebulae, like the Crab Nebula, occurs when material ejected during a supernova explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the composition and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By analyzing light curves, spectra, and remnants from these events, they can make predictions about the potential explosion of Polaris. This research will help determine whether Polaris's explosion could lead to nebula formation or impact stellar distributions in significant ways. Another critical area of study involves the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. Variations in pulsations in stars approaching death may indicate internal instability or an impending catastrophic event, offering valuable clues about the processes that lead to supernova explosions. Despite detailed observations and research, space scientists are still puzzled by the inconsistencies in Polaris's behavior. Understanding the causes behind these irregularities is essential for advancing our knowledge of stellar evolution. The investigation into the dynamics causing Polaris's erratic pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The gradual transformation of Polaris serves as a poignant reminder of the transient nature of celestial objects, even those we perceive as constants in the universe. Its potential demise or significant change would leave a notable gap in our cultural, navigational, and astronomical traditions. For thousands of years, Polaris has acted as a beacon of stability, a guide for travelers and a point of reference for astronomers. However, the study of Polaris's transformation also represents an unparalleled opportunity for science. By closely observing its behavior and comparing it with other variable stars, astronomers can refine their understanding of stellar physics, including the complex interactions within multi-star systems, the processes driving variable star pulsations, and the eventual fates of stars of varying masses. Broader implications for astronomy. If Polaris undergoes a dramatic event such as a significant dimming or a visible explosion, it would provide critical data about the later stages of a Cepheid variable star's life. Cepheids have long been used as cosmic yardsticks, helping astronomers measure distances to far-off galaxies. Any new insights into their behavior could refine these measurements, leading to a more accurate understanding of the size and age of the universe. Moreover, Polaris's evolution might offer clues about the future of other stars in its mass range. While the exact mechanisms behind its recent irregularities remain unclear, they could be indicative of broader patterns in stellar behavior. By comparing Polaris with other stars in different phases of their life cycles, researchers can identify commonalities and exceptions that will help construct more accurate models of stellar evolution. Cultural and navigational impact. The potential loss of Polaris as a constant feature of the night sky would mark the end of an era for humanity. For centuries, it has symbolized constancy and guidance, playing a pivotal role in navigation and cultural storytelling. Its absence or transformation would necessitate a shift in how we orient ourselves both physically and metaphorically. In terms of navigation, advancements in technology, such as GPS, have reduced our reliance on celestial navigation. However, for those who continue to use traditional methods, such as sailors, explorers, and amateur stargazers, the absence of Polaris would demand adjustments and the identification of new reference points. The future of the night sky. As the night sky evolves, it serves as a humbling reminder of the dynamic, ever-changing universe. Stars are born, live out their lifespans, and eventually fade or explode, each leaving a legacy imprinted on the cosmos. The eventual transformation of Polaris underscores the impermanence of even the most seemingly unchanging phenomena. For future generations, the disappearance or drastic change in Polaris could serve as a powerful teaching moment, an opportunity to reflect on the vastness of the universe and our place within it. It also highlights the importance of continued observation, study, and exploration of the stars, ensuring that we remain connected to the cosmos and its countless mysteries. In conclusion, while the potential end of Polaris as we know it may feel like a loss, it also represents a profound scientific and cultural opportunity. By studying this iconic star's evolution, humanity gains not only a deeper understanding of the universe but also a renewed appreciation for the fleeting beauty of the celestial tapestry that adorns our skies.